the illustration. So let us consider A is the set of lines in a plane. So here A is the set of lines in a plane so here relation R, the property of the relation R is of parallel. So here R is a relation defined by is parallel to. So here the here is parallel to. The property of this relation is of is parallel to. Then for we are assuming two lines in that particular plane. So here set A is consisting the number of planes. So we are going to consider what I say here two lines. So here this plane A is consisting the set of lines. So we are considering two lines for if L comma M are two lines. We are assuming two lines as one is L and the other is of M in set A. Then now, so here if L comma M belongs to R, so here then we can write it as, so this set ordered pair consisting L comma M when it is belongs to the relation R. So here the relation is of is parallel to, then it is defined by means of. So here then we have L, the relation is of the properties of parallel, then L is parallel to M. So here that implies, so here M comma L belongs to R. So here then M comma L. So here M parallel to L. So here if L is parallel to M, then automatically M also will be parallel to L. So here hence we can write this property, this relation will come under the symmetric. So here hence R is symmetric relation. So here we know when a line L is parallel to M, then certainly this line M also will be parallel to the L. So here therefore by the condition if A comma B belongs to R, then implies B comma A belongs to R, then the relation R is said to be called as a symmetric based upon that condition say here. So here when L comma M belongs to R, that is the condition is of parallel to. So here when L is parallel to M, then now here M comma L belongs to R, that is M also will be parallel to L. So when line, so here two lines L and M are parallel, when L is parallel to M, certainly say here vice versa, then M also will be parallel to M. So therefore the relation R will come under the symmetric one. Then now let us go for the third case, that is case number 3. So in case number 3 we are going to discuss about the anti-symmetric relation. So in this anti-symmetric relation, when we consider the relation as R, in which the relation R in case of A, then if A comma B an ordered pair belongs to R and also B comma A also belongs to R, then A and B must be equal, then only such a relation is said to be called as an anti-symmetric. Then now here R is a relation, we are considering R is a relation in A, that is set A, then if one ordered pair, that is A comma B, belongs to R, the relation R, and so here B comma A also belongs to R, implies when A comma B belongs to relation and B comma A also belongs to relation, then now A and B will be of equal, implies A comma B. If this condition is true, then this relation R is said to be, then R is said to be anti-symmetric relation. So here, if A comma B belongs to R and B comma A belongs to R, then that implies A comma B equals to B. If this condition is true, then the relation R is said to be called as an anti-symmetric relation. Then now let us perform one illustration under this. So here the illustration is of so here let us consider A is a set of sets. A is a set of sets. So here we are going to consider two sets. So here that is R is a relation, whereas here A is a set and R is a relation. So here R is a relation defined by so x comma y belongs to R, then if x comma y and as well as y comma x both belongs to R, so here so that if both x comma y and as well as y comma x belongs to R, then automatically say here x must be equals to y. So then hence R is said to be anti-symmetric relation. So here if x comma y is belonging to R, that is defined by means of when x is a subset. So here if x comma y belongs to R, so here if x is a subset of y and y is a subset of x, then implies x equals to y. So here if R is a relation defined by means of x comma y belongs to R, then x comma y and y comma x belongs to R, so that x equals to y, then only R is said to be called as a symmetric. Whereas here x must be the subset of y and y is the subset of x, then only these two sets will be of equal, then now x will be equals to y. So here in case if x the set is of a subset of this next set, that is y, here we have assumed A as the set of two sets. So here two sets we have assumed as one as x, the other as y. So here both the sets are belonging to the relation. In case if x comma y and y comma x belongs to R, then that implies x will be equals to y. So here then only this R is said to be called as an anti-symmetric. So here it is if and only if x is a subset of y, if first set is a subset of y and second set is a subset of the first set, then if x is subset to y and y is a subset to x, then automatically so here both the sets will be of equal. Then now this condition is true, then now R is said to be called as an anti-symmetric. So here then R is anti-symmetric.